Thank you. So good afternoon, So today I'm talking about my creative process in composing the piece, Guerreira das Pedras, that in English means like a stony warrior. So first I introduce myself and provide some context about my research. My name is Fellipe Romagna, Afonso Fellipe Romagna, and I'm a music professor and a PhD student in music at the Minas Gerais Federal University in Brazil. So I'm a saxophonist, and my current research focuses on music and technology, particularly on human-machine co-creation process, including artificial intelligence and machine learning tools. So until 2 or 3 years ago, I had no contact with advanced music technology. So, I mean, my knowledge was limited to using tools for music production, like DAWs and whatever. So I began to experiment something with some modular synthesizers, and then delved into the programming language such as Max, Pure Data, Python, SuperCollider, and others. So these presentations has, artistic perspective, approach about these things. It's not a technical approach. So the piece Guerreira das Pedras was born in a collaborative creation context within a subject of my doctoral program. We have a group called the Imaginários Sonoros, like in English is maybe Sound Imaginaries name. This group, produce art with the interactive systems in a collaborative way. It's like we have a group and the people, help each other and create a lot of things together. So in summary, what I intend to share here are using of the machine learning and AI techniques in artistic practice. Sorry, that's wrong here, but the paradigms of the machine learning and AI in the creative process with the musical interactive systems, and aesthetic intentions versus technological resources. So I'm using the methodology proposed by Maria Balma, available in the book Composing Interactions. Therefore, all the graphics I will share here follow the methodology proposed by the author. All our theoretical framework is based precisely on the following words by Balma. So, how do technological and aesthetic choices in this process influence each other in their artistic practice? So I believe that by bridging the gap between the aesthetic and technological, important new insights can be gained, and it would be made easier for artists entering this field. So to build up on previous work, generated knowledge from other artists. So that's main, theoretical framework for our concept of this piece. So let's talk about a bit about the piece. So in my artistic works involving musical or audiovisual system, interactive systems, I always like to start with the poetic aspect to identify the strategies and tools that will be used, as a Bauman proposes. So in this sense, the first artistic motivation of this work was to talking about a recently discovered butterfly in Brazil, already endangered, like other species, called the Guerreira das Pedras. She is here in this picture. This is a butterfly, my inspiration. So butterfly have always fascinated me, both for the aspect of the mutation and for other curiosities. So such as, sorry, just a second. Such as some popular beliefs that they can be the reincarnation of loved ones who have passed away, or can also be a better feeling related to ourselves. But one of the most curious for me things is that we can't hear them. So they are ancient beings that often go unnoticed by sounds. So with this in mind, I remembered a character named Maurício Babilonia from Gabriel Garcia Marques' books, 100 Years of Solitude. It's a very famous book here, whose surrounded by butterfly, this character. So wherever he goes, butterflies are always around his head. So I asked myself, how could I represent this theme in this poetic figure in a piece? So I'm a saxophonist, so I have always reflected on how the saxophone is a noisy instrument in the terms of the keys on the other parts of the tube. So, and how we always trying to reduce the sound they make. So drawing a parallel with the butterflies, I came up with the idea of working with the sound of the keys separately to give voice to these sounds that that often go unnoticed. So it's simulating the keys with the flapping of wings. So that's how I started to writing a piece for saxophone, dance, and video. In this sense, I will share the more technical aspects and how they related to the poetics, the piece. Now, it's a graphic, all the symbols here, it's available, that means, in the Maria Bauman's book. So this flow of the connections of the piece, so we have a saxophone, microphone, interface into the SuperCollider, and we have a dancer, a smartphone capture, the hands movement. I used the MediaPipe library in Python, and into the open frameworks and a video, like output, as output. So for the sound and music, to produce the desired effect, as I was studying some, machine learning tools applied to music, I came across the Flucama project. It's very famous here in this conference. And a specific object called the buff NEM. So this object allows for our decomposition, enable me to process the sound of the keys differently from how I process the sound of the saxophone in real time. So the buffer NMF, according to the project's documentation, it's very hard to explain for me. So buffer NMF employs no negative matrix factorization to decompose the magnitudes of a spectrogram into a user-specified number of the components. So after several analysis tests, in our case, the use of the 3 components proved to be sufficient for separating the key clicks and similar noise. So each component, it's represented by the combination of the 2 elements. Let me see this image. So a spectral template basis and an amplitude envelope activation that they are stored in the buffer. So activations and bases can be used in various ways, either for the resynthesis of the decomposed audio or for training and decomposition of audios different from the source used as a data set. So following training analysis, the playback process proceeds using the fluid NEMF filter object. This object divides the signal in our piece into the distinct audio channels based on the set of the spectral templates provided by the buffer NEMF analysis. So non-negative matrix factorization is applied to a single spectral frame utilizing the previously provided and stored base in the buffers. So for the training process for this piece, the strategy we used was to produce the saxophone recordings. I recorded a lot of samples with a great amount of the key clicks and noises, while also having simultaneously tube sounds. So this allowed us to apply separate effects processing exclusively to the key sounds of the instruments. So it's that's the diagram that represents that idea. So does the sound of the saxophone keys had a delay and granular effects, while the sound of the saxophone tube had only reverb. So let me see. So the piece was produced in ambisonics for an 8-channel systems using the YAN plugin. The sound of the saxophone tube was in stereo, coming from the speakers positioned at the sides of the stage. And the sound of the saxophone keys with the process played through the other 6 speakers surround the audience. First, that idea was that, just like the character in the book, Maurício Babilônia, the keys could represent butterflies around the audience's heads, it's like that. And finally, communication between all programs, was done via Open Sound Control. So we use 3 programs, SuperCollider, Python, and Open Frameworks for that. This is a example of the code in SuperCollider. All the things available in the help, I use them. I think that's incredible in SuperCollider. It's the help. It's it's very useful, and so thank you for the research of the Fulcoma, Ted Moore, and other guys. So about the dancer. So the dancer is the piece acts to represent the process of butterfly's mutation in our poetic idea. So our idea was to capture the movement of the hands to generate a video and also sound movement. In this sense, given the time and knowledge available, we choose to use a ready-made hand recognition tool. So we opted to use MediaPipe, a Google library, which is usually used mainly for security devices, maybe. So in the first part of the piece, the dancer moves without using her hands, so like a butterfly trapped in a cocoon, trapped in a cocoon. So as soon as she begins to break free, the movement of the hands produces the video, but also interacts with the sound. So thus the movements she made to the left and right altered the azimuth angle of the ambisonics, so moving the sounds between the speakers. That's a diagram. Here I have some pictures of the presentation. Technical writer. So finally, for the video, we use the Open Frameworks. So I confess that it was extremely challenging for me to carry out this work in the program because I had never programmed in this language before. So I opted for something simpler. So for each XY coordinate provided by MediaPipe, I simulated the movement of a mouse in Open Frameworks, which generated various grants on the screen. It's a very, very simple image. So these grants were not fixed and disappeared after a certain time. So the idea was, also that the grants could represent the butterflies around the dancer. So it's the same, poetic figure of the Maurício Babilônia. So all the more technical details are available in the paper in case anyone is interested about that. It's a very short presentation. So finally, I represent my considerations regarding this work. So please allow me to read it for this final final consideration. So in this paper, we have presented the creative and compositional process within multimodal composition involving instrument, dance, and audiovisual systems. It explores Marie Bauma's methodological model to present this process. emphasize a conceptual approach over focus on rapidly changing technical specifics. So really highlights how poetic and allegorical elements may have a crucial role in guiding the production, development, and experimentation stages, helping artists use interactive means to filter and refine the vast array of the computational possibilities. So creating works involving interactive systems increasingly requires interdisciplinary expertise. So with artists often navigating this intersection of knowledge, even when collaborating with a specialized professional, as demonstrated by the composition, by performance, of the Guerreira das Pedras, and other artistic projects held by Imaginário Sonoro. So if the diverse open source technological tools employed were as relevant as the ideas and poetic allegories that motivated this project's composition. So along the side, the theoretical and conceptual elaborations of Bauman and other authors focus on the specific creation involving interactive systems. So we hope that an account of the experiences present here can contribute as possible approach for the other artists and researchers. I have a short example of the video here. We had a problem in the concert because our main camera, turned off in the middle of the concert and, didn't record anything. So I have the sound available of these concerts in my SoundCloud, and I here my QR codes of the SoundClouds and my profile on Instagram. If anyone has interest of the something of the piece. So I share with you this. It's a smartphone recorder, so we have a bad sound and bad image. Sorry, but it's an example of the I presented here. Sorry, I think that's the time is over. So thank you for everyone, Hank, for the event and the organizer of the event for opportunity, to share of my work.
Hi, my name's Rohan. I'm going to talk about a structure editor for SuperCollider programs. As a quick preamble, the system I'll be discussing runs in a browser, and instead of preparing slides for this talk, I've prepared a sequence of small programs which I'll step through and discuss. If the texts aren't legible for you, don't worry, I'll read them aloud. At times I'll mention the controls. They're in 2 rows at the bottom of the screen and likely too small to read, but they're not important for the talk. After discussing each program, which will describe a simple SuperCollider sound, I'll briefly run it. Hopefully this will make the meaning of the drawings I'm talking about clearer. So to begin, Block SuperCollider is a visual editor for SuperCollider synthesizer programs. Ordinarily, programs are sent to an in-process WebAssembly copy of the SuperCollider synthesizer, which can be started by pressing the begin button, which I've already done. This program sounds like this. The status area is located to the right of the begin button. It shows the number of sounding unit generators. This program describes a graph with 83 vertices. Programs are written as sets of interlocking graphical blocks. Each block represents one element of the program. The sine oscillator block represents a sine tone, and this program generates a quiet sine tone at 440 Hertz. To listen to a program, press the play button. To stop listening, press reset. The block editor has two parts, a workspace where drawings are constructed and a toolbox from which the elements of the drawings are taken. Blocks can be moved about the workspace and connected and disconnected from each other using the mouse. The Fit button resizes the block program so that it fits inside the workspace. The toolbox contains instances of the blocks the system knows about, organized into categories. Blocks are fetched by dragging them out of the toolbox and into the workspace. A toolbox is an organized collection of block programs. There can be any number of toolboxes and they can be switched between as required. The T button selects between the complete toolbox, which has nested subcategories, and a search, and a small toolbox, which includes only a subset of the defined blocks arranged into a simpler structure. A shadow block is an editable but non-movable block connected to a parent block. The toolbox entries ordinarily have shadow blocks at each input, specifying a default value. Blocks can be placed on top of shadow blocks to override them. The frequency and reciprocal of Q inputs have shadow blocks beneath the list blocks. Editing a shadow block underneath there. Editing a shadow block value creates an actual block and connects it into place. So. Blocks are drawn in colors according to category. The colors are shown to the left of the category name. Categories are grouped into families, also indicated by coloring. This program includes blocks from 9 categories and they are drawn in 9 colors. There is also an outline drawing mode. These drawings may be more suitable for printing or for non-color displays and are selected using the outline button. Programs may include notes written in simple markup language, allowing for a kind of literate programming. This text is such a note. Notes are displayed to the right of the workspace. Layouts allocate more or less space to the notes and set the font size. The text displayed on a block is called the block message. It is distinct from the block type and is not stored as part of the program. The naming schemas button selects between alternate naming schemas. Ordinarily, the symbolic naming schema is selected. There's also a text naming schema. In the symbolic naming schema, the block and each of its inputs are named using a brief Unicode string. Names in this program include pulse and lambda for blocks, new and left arrow for inputs, and M right arrow, new, and floor for menu items. In the text naming schema, the input names are elided, emphasizing the expression tree nature of the drawings. Block drawings are evaluated by translation into a text language. Block SuperCollider programs in particular are drawings of simple programming language or SPL programs. The text below is the SPL translation of the drawing at the left. The relation is particularly clear if the drawing is pictured using the text naming scheme. There is also a translator in the other direction, from SPL programs to block drawings. At left is a translation of the program below, posted to the SuperCollider users mailing list by Paul Jones in 2007. The system includes translations of a few hundred small programs listed in the program menu. These include SuperCollider example programs by James McCartney, a set of 140 character haiku programs by Frederick Olofsson, a set of one-line programs by Lance Putnam, and this program by Dan Stow. Since block drawings are evaluated by first being translated into text programs, it is straightforward for the system to evaluate text programs as well. The Play Text button will play either the selected text or, if no text is selected, the paragraph at the cursor. This program is by Frederick Olofsson. The text in the notes area can be edited. So this is playing the drawing. And this is playing the text. A stereo sound can be made by writing a list of two mono sounds. The list block constructs lists. The gear button allows slots to be added and removed. The pink noise block generates pink noise. The brown noise block generates brown noise. Duplicate constructs a list by evaluating a lambda block the specified number of times. The lambda family of blocks represent procedures. This particular lambda block represents a zero-argument procedure. The return input indicates the answer value. Display arranges a list of sounds equidistantly across the stereo field. The replace button crossfades between sounds. An idiom is a small program that is often repeated. Duplicate lambda is an idiom, and the toolbox includes it in the list category. This program is the noise burst sweep example from SuperCollider 2. Overlap texture T is another idiom, in this case combining three blocks. Overlap constructs a texture by overlapping multiple copies of a generating function lambda, which is reset at each cycle boundary by T. The mouse X and mouse Y unit generators are not implemented at the in-process synthesizer instance. However, the system simulates them by writing the window mouse coordinates to synthesizer control buses. The assignment block sets the value of a variable. Because block drawings are of trees and not graphs, if the answer of a block is to be used in more than one place, it must be named. This program is translated from a one-line SuperCollider program by Lance Putnam. It's another of the small programs included with the system. All unit generator blocks with an output port have multiply and add inputs for adjusting scale and bias. Unlike in SuperCollider language, the adjustments are made after the block is defined and do not form part of the list processing behavior of the block. Unlike in SuperCollider language, block programs must be connected. There is no implicit framing mechanism. In this program by Frederick Olofsson, the first argument block attaches the local out block to the unit generator graph. Demand rate unit generators are not scheduled on either the audio or control rate sample clocks, but instead calculate values when requested to You all know this. In the program, in this program, a short sequence is played simultaneously on 3 different clocks. Sound file acquire fetches a sound file specified either as a URL or as a key into an extensible dictionary and answers a list of buffer numbers. The context menu for each block includes a collapsed block entry. It elides part of the block drawing, in this case of DX7 patch data. Blocks can specify input and output types, and these are checked by the editor. The duplicate block checks that the lambda input is a procedure of no arguments, and that the count input is a number. We can't move the random number block to the count input, just bounces off. And we can't move the oscillator block to the duplicate, the lambda input there, just won't go. C is a control field. When the text of C is edited, the edited value is sent to the synthesizer. C is both part of the definition of the program and, while the program is running, an interactive control for the synthesizer. C does not have a direct textual analog. This is the second last program or slide of the talk, so to briefly conclude. In this talk, I've been showing ways in which the block editor resembles the text programs that it encodes. But this last program shows one way in which block programs are not like text programs. The list mutator, which allows for slots to be added and removed from the list, illustrates a particular distinction that I would like to draw attention to. It is an instance of a block-specific meta editor. It edits aspects of the structure or shape of the block itself. This aspect of blocks, that they can have special purpose meta editors, that they can change their shape, that they can store and retrieve arbitrarily complex meta values, and that the editor library directly supports these behaviors, makes block editors a potentially interesting environment for writing music programs that are, at the same time, their own virtual control surface. These are the acknowledgements. The synthesizer called SuperCollider is by James McCartney and others. The WebAssembly patches are by Hans-Holger Rutz and others. The block editor library called Blockly is by Neil Fraser and others. The parser library called OhmJS is by Alessandro Barth and others. Block SuperCollider is at that address, and there's more details about it, including the extended abstract for this talk. Thanks for listening. Thanks to Sam and Ted for organizing. I think there might be time for 1 or 2 questions.
Yeah.
Hi.
I just wanted to gush for a second how gorgeous this thing is. Like, it's just, my hat's off to you. This is just a really beautiful implementation and very usable. You should be very proud of this work. I think it's amazing. That's all.
Thanks. Yeah, that was very nice. Thank you.
Yeah, Victor. Am I audible from here or?
Yeah, I can hear.
Thank you. Your second last slide, the C construct, that's a block-specific thing that you mentioned that doesn't have a direct analog in the text form. So that just got me wondering, just is the process of translating text to block, is that generally automatable, or does it take a significant handwork to make it work? And in such cases, it's also like how's the reverse process if you want to translate block to text? Are there any pitfalls?
No, so the block to text, the way that the library works is that that's how anything happens. So the block to text translation is completely perfect. The block definitions all have to be able to print themselves as a program. Going the other way, yeah, it needs to be the right, the program needs to have only the things that the block system knows about, or else it can't go that way. It's automated, but it was one of the first things I wrote, and they've changed the block library a bit since then. So it prints the programs in a slightly obsolete format, and then you need to translate them one more time. So it's much clunkier. It doesn't happen in the browser. It's a separate program written in Haskell, but it should go in the browser. I just haven't done it that way. But yeah, it's a bit clunkier.
Thank you.
Other questions? I have a question, Rohan. Do you have users of this? Have you given this to people that maybe that are familiar with SuperCollider or aren't familiar with SuperCollider? Like, how has this hit people who might be, I don't know, new to programming or new to synthesis, or is the block feature enabling use in some sort of novel way?
I haven't really shared it with many people yet. I sent it. Frederick Olofsson was a very helpful early guinea pig, but he's super expert, so that doesn't really answer your question. I've shown it to some friends who are music people, but not computer people, and I've written some small programs for people, just very simple things, and people, I think they find it more approachable. I think that's one of the ideas about block systems. It's less intimidating, but actually I have no experience with actually trying to convince anyone to use it or anything. It's just been it's just something I made for myself, essentially. But it's there, and people can use it if they want.
Great,
so I don't know how it goes in the real world.
Great, thank you, Rohan.
All right, thank you for bearing with me. My name is Victor Chan. I am currently teaching on the faculty at North Central College in Naperville, Illinois, alongside also teaching at the University of Illinois, Springfield. My presentation today is titled ChessSynth, or that was the title I submitted under, and I've since upgraded that working title to a real title. My title of my project called Fork. Etymology being, in chess, a fork is the act of taking one piece and simultaneously threatening two or more, forcing your opponent to choose which one to save. And also because in SuperCollider we got .fork. So fork is a framework for automatically composing a soundtrack to a chess game. So we got this chess client right here. I wanted to use SuperCollider to I should probably stay noise and face the microphone. Use SuperCollider to read the data from the chess game, represent my moves in a symbolic manner that reflects not only what's happening in bit by bit in the moment, but also by kind of reflecting the progression of the game. To do that, I've got I divided this I established a kind of hierarchy of sound control. So each move controls a combination of direct control over immediate sounds and indirect control over continuous sounds. So I'll just show, taskbar keeps on jumping over here. Here we go. I'll show you what I mean by that. Gosh, everything is on the wrong window. So each move, it controls a direct tone, which is a sound that right away when a single tone that you make a move. Slightly farther down, I'm on this chord. This is each move will change the baseline and therefore the root of the chord that's being played, the harmonic support. And what happens after that is that each tone is fed into a list of tones that are repeated in scrambled order and in verbatim in exact order simultaneously with the background melody and the high melody. Background melody is going to be very, very fast. And then the high melody is going to be kind of slower up higher. Further down the line, each chord is represented further by an arpeggiating set of notes. So the notes that form the chord are played in arpeggiated, broken in steady 16th note rhythm. And they're also represented intermittently in the high percussion motif. So I'll show you a sample realization of what might be happening here. These direct tones, these are representing each individual move. So I got some algebraic notation here, pawn to e4, black responds pawn to d5, and white will respond by capturing d5, etc. Each of those gives you a tone. Simultaneously, the bass line will be happening. You got this steady arpeggiated rhythm happening here. And look at the high melody. It's reflecting exactly the same notes that came out of the direct tone: C, B flat, D, B flat, etc. Whereas the background melody is taking these tones and then scrambling them and playing in a faster rhythm. How these notes are selected is I start with a C Dorian mode. And what happens is I track what's happening in the chess game primarily by tracking how many attacks each piece is making. So I'll give you an example here. If I move my pawn e4, no new attacks are being generated. And in such cases, it'll center around the C minor triad or C Dorian triad, C, E flat, and G. In contrast, if black responds with pawn to d5, they are initializing attack on this pawn right here because pawns can attack diagonally. Simultaneously, this white pawn also has has an attack. So two new attacks are being generated. When new attacks are being generated, it will gravitate towards the B flat major triad, so subtonic, the 7th scale degree in the Dorian mode. So each of these are reflecting a move away from the tonic. If I respond in kind, let's say white will take that. What would happen is another the B flat triad, signifying that something has signifies that attack has been taken. So either generated attacks or fulfilling attacks destabilizes and moves us away from C minor, whereas any notes that do not generate attacks puts us back towards the tonic. Now, that's simply the melodic portion. I want to talk about the harmonic portion now. And that's represented by progressions and resolutions. These are SVGs, so they open Chrome. These are progressions. Every time we move to an unstable state, whereas such as generating attacks or taking pieces or making checks. Baseline, which starts at C, it will go in any one of these directions represented by the web. So, and these are by random chance. C has a chance of progressing towards B flat, towards E flat, towards D. By this point, I'm talking about triads. So C minor triad, D minor triad, E flat major triad, etc., as reflected in the C Dorian mode, or the F major triad with the A natural. And every time I progress by generating attacks or by taking pieces, it will move in any one of these possible directions. I chose it like this because of to reflect several more flexible paths than would be possible in a traditional tonal framework. So by avoiding the leading tone using a subtonic, the subtonic to C is a little bit less, it carries less tendency with it, but it still carries enough. In my opinion, the B flat to C has enough weight in its resolution that I can maintain C centricity as a tonic, but also D to E flat can carry a sort of centricity as well. that's this use of an auxiliary leading tone and these intensity tones is how I designed some of these progression possibilities. Compare that to these resolutions. So when enough moves have happened without any attacks or without captures, the chord will accordingly resolve. And for example, I would say B flat has a possibility of it resolving to E flat because 5-1 in B flat to E flat. But B flat also resolves to C, its original tonic. So using that subtonic relationship, a little bit less less clear tendency than would be in functional harmony. But again, I want this level of flexibility and variability. A lot of this is random chance. So every time I render a game, it's going to be sounding subtly different. So enough of that. I'm going to go ahead and start running a game here. I'm going to first reset this game. Okay. Here we go. We have a few moments to get SuperCollider ready for this. All right. Right now, I just have the bass line. It's in C. Then the synth depth to carry a little bit of a detune. It's actually a collect of 15 LF sols, and each with slightly a slight detune to it. So either multiplying it by any value between 0.99 and 1.01. And that gives us kind of less swirly quality so that if you are in a game and you're just really indecisive and don't know what to do, I'm trying to make sure that hearing this won't go too stale. Start playing. Right now, that was a G. It takes a note from the C minor triad because no attacks are being made. And now if I respond with an attack, that's an F, it takes from the B flat major triad. I'm not going to respond just yet, and I'm going to play very, very badly. So if anyone plays chess, I am sorry. I'm going to demonstrate a few possibilities. And in the background, you start to hear those notes being repeated in random order. I'm going to take a piece now. And once I take the piece, the background melody and the bass melody start moving. There it goes. And every time I take something like that, you can hear the bass line shift to reflect a kind of a resolution. I do something exciting. I'm going to check. Special tone associated with check. And if I go a few moves without anything exciting happening, baseline will resolve. This is an, I believe this is an A. And this resolved to B flat. The A natural to the B flat as a leading tone. That's why I let A have B flat as a resolution. I'm just going to play along a little bit more. Just make it, So I took that piece, and therefore it's going to progress again, going from a B flat to a G minor. That's a progression. And then take another piece, G, B flat, another progression. And again, if I go a little bit further without taking anything, it's a B flat, and then should So now B flat resolved to C. The other possibility would be to B flat to E flat. So there's always some variance here. Even if you can play the exact same game, you're going to get something a little bit different. All right, I'm just gonna let this run for a few moments longer. Running out of time. So I think I can end it there. Do we have questions?
What happens if there's checkmate?
Checkmate. I have a I don't know if I can give you a quick checkmate right now, but I'll give you a check. So there's a special tone attached to check. It's treated as a escalation, just like as if I was capturing a piece. There's a special tone if I capture the queen, by the way. Delay effect right there. Checkmate will give you a special tone, and then once the detects that the game is ended, then it will just kind of fade out.
Is there oh, okay, I was just thinking, right. Yeah, I guess to that. No.
What's the number on there?
3. I guess, well, also to that end, is there any sort of anything special that happens when you take away an emphasis on?
There is not. I wish, but yeah.
What about a theme for the white and a theme for the black? You have like a
I considered that.
one guy's ahead, one person's materially ahead, their theme plays.
I didn't want it to be such a like one-to-one correspondence of the of who's winning, who's not kind of thing. It's just like, especially from my perspective, I'm going to be losing 99% of the games I play. I'd want to be able to hear more than the losers think. More generally, so far it's just one singular set of audio. I considered like, because I want to potentially move this towards online chess and maybe make a better client for it. And was considering the idea of whether I want both players be hearing the same thing or something a little bit different. I haven't decided on that yet. Right now, it's just not really conducive to the idea of themes. I think one way I could think about it is if white has certain tendencies that I can resolve, that I can translate into based on the moves the notes is generated, but I'm not sure if it would be that viable to hear a clear difference between the way white plays and the way black plays. That's an interesting idea, though. I'm still coming up with different ways of representing them. So, yeah.
I was curious if you had thought about the possibility of considering score evaluation. So if you're looking at a chess engine like, say, Stockfish or Komodo or something like that, they'll give you a score. And obviously, if you're listening to this as you're playing the game yourself, then maybe that's kind of cheating in a way. But I guess if this is intended as a sort of like sonic backdrop to people listening en masse online, which happens a lot, that's something that just kind of, I feel, just follows naturally, because often what you'll see on these websites is they have this like status bar beside the game, and you see it go up and down depending on who's doing better and who's not. Have you considered that?
Yes. I'll scroll down the browser a little bit here. Where's my cursor? The data being generated here, it actually does have just an outcomes evaluation down here. So it's a parameter that I'm thinking of incorporating in the future. I do want it to be kind of removed from a player's own personal skill level. I don't want it like someone, again, terrible at chess to have the music that generated tend towards a certain way. And I also don't really want it to serve as a guide. It's just like, oh no, I'm in trouble. I just hung my queen, and then the music's gonna tell me I'm in trouble. I don't want it to like really interfere with traditional chess playing. I want it like if people want to listen to chess music while they play, this could be one way to doing it, and doing it more natively bundled into the application. Eventually, I'll probably incorporate Stockfish and they take more of these values, but exactly how is kind of it's in the works. Yes. Great, thank you.
Figuring out which is longest, scaling that to the window size, and scaling everything else to match, so that the vertical position of each part here lines up temporally. Let's see. Yeah, so setting the tempo, there's a number of different ways to do this. I can kind of click into this tempo area here, and it brings up this tempo list. So as we can see at beat 0 here, part 1 is at 118. I can easily change that here to whatever I want. And there we see it has rescaled this part. It is now at a tempo of 67, and it's rescaled everything else to match. I can also change the tempo at any point, maybe at beat 7. I wanted to change to 88. There we go. We can see it's kind of provided a thicker little white line here showing that there's a tempo change, and it has scaled the vertical or the horizontal spacing of the beats to be in the right proportion to everything else. Another way to change the tempo is I can alt-click at a place here and bring up this kind of more detailed editing window. And I can, set the tempo at the beat that I clicked into right here. But I can also, and this is what I often do, set it to a particular ratio with another. So if I want this in a 9:5 relationship with part 1, there we go. It has calculated that for me. It's now at a tempo of 120 3/5, and 9 beats in part 2, lined with 5 beats in part 1. There is, I also have a way to map tempos to low frequency oscillators, so that it doesn't have to be just a static tempo or immediately changing tempo at a certain point. So I can say, maybe I want this tempo to follow sine wave between 100 and 150. Let's make that a bigger range. Let's say 250 beats per minute over the course of, I don't know, 12 seconds. And we can set that. Let's make that a longer part so we can see it more clearly. There we go. So we can see the beats being closer together where the tempo is faster and stretching out where the tempo is slower. I'm using a class I built to kind of calculate those positions, using kind of filling a signal with the tempo at every specific point. And I'm using that to convert to beats, how many beats have passed at every specific point, so that it can know exactly the placement of each one of these beats and draw those nice little vertical lines for me. Yeah, let's keep moving here. So setting the meter, I can click into any given spot here, set the meter. Obviously any normal meter will apply. Now it's in 7/4 starting at this place right here. I also use often fractional meters in my composition. I find that much more intuitive. So if I say 7 and 2/3 over 4, there we go. It's got those little thirds of a beat for me at the end of each measure. I find this much more intuitive than saying something like 27 over 8 or whatever it would be. This is just, I'm coming from a background as an instrumental musician, a jazz musician, and if I see 7 and 2/3, I can kind of immediately understand what that means. So that's been the way that I approach situations like that. The denominator doesn't really have an effect here by itself because it's assigning that tempo to the value of the denominator. So if I changed it to 7/8, it would be the same thing because it's then taking the 8th note as the tempo I have set. But it does matter relative to the fractional beat here. So I can say 7/4 plus 2/3 over 2. And here we go here. So each of these is a third of a half note, essentially. So I have ways of kind of combining various fractional meters here. Alignment, it does not need to simply align at the beginning of every part here. I can align any point in any part with any other. So say I want part 3 here, beat 7 to line up with part 1, beat 12. And it should do that. Let's get this back to a simpler, let's switch back to a list tempo here. There we go. That might be a little bug I need to fix with the LFO tempos. But so we can see here that we have this alignment point. It's showing these little dashed lines between to say these beats line up precisely. I've built a little fraction class so that I can compute everything as fractions instead of floats so that it can have a precise relationship. So yeah, alignment, yeah, this focus line, you've seen me kind of moving this focus line around. It's a simple control click. It finds the part that I'm closest to, the beat that I'm closest to, and kind of snaps it to that, and then displays information about that. So you can see over here in part 1, that's right at beat 10. The tempo at that point is 88. In this part, we're at beat 16. Well, because it only goes 16 beats, let's make it longer. There we go. In part 2, we're at beat 16.71. Tempo at that point is 120 3/5. In part 3 here, we're at beat 4.43, and the tempo is 113. So you can kind of see exactly where one part is lining up with other parts and what is happening at that point. We can also see down here the exact time in seconds that has passed since the start. Inputting rhythms. So I can kind of quickly sketch out rhythms in here and manipulate those as well. So if I simply click above the part, we get a little circle here that indicates just a note is happening. Again, it finds the nearest part that I'm clicking to, snaps it to a beat, and inputs a note there. I can click underneath to remove that. I can also, if I click again on a note, this is the symbol for a long note, and then I can put a rest somewhere to say that's where the note's stopping. These buttons along here allow me to use subdivisions. So I'm not stuck to just rhythms on the beat. I can pick any of these subdivisions I like. If I want some 16th notes, it'll snap to the nearest 16th note instead of the nearest beat. Highlighting, yes, I can, if I shift click, I can highlight sections here. And what that allows me to do, well, a number of things. Number one, if I have 16th notes selected here, I want just a run of 16th notes, so I can highlight and turn those on. There we go, 16th notes filling up that highlighted section. I can also, these division buttons down here, maybe I want every 5th 16th note on from here to here. There we go, it's filled that in for me. It also allows me to drag and drop these rhythms. So what got me into polytempic composition was coming across Conlon Nancaro, and he uses a lot of canon, setting the same rhythm against itself in various tempos. So I can easily do that by grabbing this, setting it up here, just put that in another part at the other tempo, and I can see how those line up with each other. I can also, just kind of push things around to move them quickly. I can zoom in, which is important when you get a longer piece. So maybe we have something like 40 measures here. That becomes unworkable, but we can highlight, zoom in. There we go. We've got a portion of it. This bar here shows what proportion we're looking at. We can scroll through to, interact with any, arbitrarily small section here. Playback. So the primary function of this is now playback. The primary function is, this workflow of working with polytempic ideas swiftly. But there is a basic form of playback here. And if we just hit play, you hear that? We cannot hear that. Oh, haven't booted the server. Let's do that. So yeah. It's a bit quiet. But hopefully you can hear that at least a little bit. We've just got some very simple booby sounds here. And I have a pitch entry over here. If I want to control the pitch, I've made a little class that parses this notation string, like E flat 3. It takes that and converts that to a MIDI value. I am, using clocks here. Each part starts a new clock at that tempo. If there are tempo changes within that part, those are scheduled on the clock at the start. The positions of notes and rests are scheduled in there, so it can just kind of compute that really quickly when I hit play, and it knows kind of how that's going to work. Yeah, I can play, maybe I don't want to play from the start every time. This was something I came across when I was developing this. I would, be 40 measures into it, and I'd have to play it from the start to get to that point. So I've got a simple little play from the focus line here. It'll jump right in there. So that lets me, did that do that? That lets me just kind of, swiftly get into a specific spot and work with that, hear that concretely, the relationship between the tempos and rhythms. I can change this. There's I got a little click sound here, just a very simple. Oh, that's part one. Yeah, let's get it on. So we can just hear a little of that. If I make that long, it's like a little basic, little simple crash. Nothing fancy here, but just a way for me to more concretely hear what I'm working with and get a sense for how it works. There's a little piano synthesizer here. I just found a class. So if I want a less electronic-y sounding sound, I can use that. I've also, how am I doing on time here? I'm running out of time. So it got to a point where I wanted to be able to hear melodies and not just a single note. So I can assign sequencers to each part here. I can enter notes in here in melody, and it will send OSC messages to the sequencer at the right time, and I can hear those melodies being played. So the point of all of this is just for me to be able to very easily and smoothly and quickly test out ideas in my compositional process, and concretely be able to work with complex tempo relationships that I wouldn't just be able to automatically hear in my head. Let's do a little example here really quick of a piece I wrote. It's going to take just a second to load because there's a lot of stuff going on in here. Here we go. So open the synthesizers. So this has three distinct tempo streams. Each one is following a constantly changing envelope between the same tempos. I think they all go from 60 to, let's see here, 60 to 240 over different periods. There's one that's 15 seconds, one is 17 seconds, and one is 16 seconds. So these kind of start in sync and then diverge as the rate of tempo change changes. Let's see if you can hear okay. You get the idea. I want to quickly play for you. This was performed in 2023. I wrote a set of miniatures for jazz sextet, Polytempic things. So this is just about a minute and a half. I will play it for you real quick here.
We have time for, let's take one question for Derek.
First of all, it's beautiful, like, thank you so much for showing it. Just wonder, like, if, did you, I don't remember, but did you say that like, there was like record for the playback? Was there a function?
Yeah, you can record the playback. So yeah, just get a simple recording of that, and that's useful for sharing with performers so they can get a sense of you know, the proper tempo structure of it.
Yeah, that was what I was curious, like your experience with like using this like for actual performance with ensemble, that like, did you like give the playback report for them and how was the
So
experience?
I do convert this into standard notation. I use Lily Pond because I haven't figured out another way to write polytempic music, engrave it. Lily Pond is kind of a pain in the ass, but it works. I've developed a function to, so something like this, right? I need to know the specific time of every single beat in every single part. So I've got this export beat function, which kind of exports the time of every single beat, the duration of every single beat, and a little bit of a kind of a skeleton outline of a Lily Pond formatted thing, which just kind of scales every beat to the right length. just a big list of scaled beats with like just nothing, nothing in there. And then I can input the music into that. So I don't have to do that manually.
Thank you so much.
So do we have time for
Fast?
another question?
Yeah, how many hours of rehearsal did that group in recording?
We didn't have a ton. What did we have, Mike?
Maybe like
4 hours or something. They really did a good job on very limited rehearsal. Yeah.